Okay, so here's the recap for the Brick Breaker game. First thing we did was to make our own class. So far you've seen the code for two classes and been able to muck about inside program class and in the game 1 class, which was based on the XNA game class. So really game 1 is a subclass. Now you've also made use of other classes from other namespaces such as maths, texture 2D, keyboard and so on, loads of other ones. Most of the ones that come up in light blue are classes that have been provided for you, usually by XNA and Monogamer. But it is fairly easy to make your own class. You can add it to an existing code file alongside other classes. For instance, you could put a class in the same file as your game 1 class. Or, as we did, we could insert a new code file to contain it, which for a lot of people is the preferred approach. Now, classes must be within a namespace, any namespace, but if it's not in the same namespace as the code that tries to use it, then you'll need a using command. Classes can contain attributes, which is basically variables, and methods, which are basically functions. A bunch of other stuff can go in there as well, but that's the two main things we're worried about at the moment. For example, a namespace could contain a class, which then contains a variable and a method, which the method of course contains code, which is the ultimate goal, I suppose. Now these methods are made up of a whole bunch of things you should sort of recognise by now. The first thing is called an access modifier. That can actually be left out, but if you leave it out it will default to private. So although you don't see it, it's still there. So it can be private or public, or a couple other options, but mainly private or public, which lets you know whether other classes can see it or not. If it's private they can't, if it's public they can. It will have a return type, or void. So it could be something like integer, string, texture 2D, or void. You might find other words in here, such as static or a bunch of other things that we shouldn't really worry about just yet. Then the identifier, which identifies a name that identifies the method. And it is case sensitive, so a capital S there must be used if you call this method. And then inside parentheses, you have the parameters. It looks a bit like a declaration. You say what kind of thing you're expecting to receive, and then you use an identifier to refer to the name of some data that you do receive. And every time you call up this function called doStuff, this method called doStuff, you need to provide a floating point number. And whatever number you provide, within these brackets, the method body, the actual code, will refer to that number as input data. So the code goes there, and in this case, because we do have a return type, we need to return something. I'm just going to return the number 1 as an example. We learned about, or rather we used, object states, in particular the game state. So the state of an object can refer to the sum total of all its data, if you wish to go that route. That does make it kind of hard to work with though. You can also just specify a few particular states, named states, to describe what the object is doing. For example, in a game, you might have a game state, and the states could be things like pause, play, etc. And you can describe the states and the transitions using a state diagram like this one. So in the state diagram you have all of the states in little boxes and arrows representing transitions. We could have written something on these arrows explaining what causes the transition, but I've glossed over that for the moment. And this is a fairly typical layout. You start with a splash screen that goes to the main menu. From there you can go to the options menu and back again, or you can start the game. During gameplay you can go to the inventory screen and back, you can go to the pause screen and back, or you can finish the game by winning or losing. You then get the game over screen and then finally return to the main menu. These are all different states that the game can be in, and it will do different things, draw different things during those states. And you can represent game states a bunch of ways. If you only have 2 of them, you could use a boolean. I think that's how we started off. Boolean true or false for whether you're at the main game state or not. But that quickly runs out of states for you, and when you need multiple game states, you should probably use a number, an integer. But remember that integers can be represented as enums instead, enumerated types. And if you do go that way, make sure to declare a variable that actually stores it as well. So there's an enum called GameState. You'll see it's in light blue. That indicates that it's not an object. So the game state just defines that every game state could be one of these: splash menu, play, etc. But we need to then declare a current game state, which is going to be a game state. And that way we can change between states like this. We also saw a bit of work with vectors. So two of the most important things you can do with vectors are to get the length of a vector and normalize a vector. So a vector is just a collection of x and y components. These are just floating point numbers. And we can use Pythagoras theorem, I'm sure you should know that, to calculate the length of the vector. So the length L is basically the square root of the x squared plus the y squared. And that will get you the length of the line that's made up of those x and y distances or components. So if this vector is used to represent a position, then the length of the vector tells you how far away it is from the 0 point, the origin. But if the vector represents movement, then the length is, well, essentially it represents the speed of the movement, but we don't know what direction it's going. The other one, normalization, it means taking a vector, an x and y, and shrinking it so that the length would be exactly 1. And when we do that, it's called a unit vector because it's 1 unit in length. So the normalized x is the same as the regular x divided by the length, which we just worked out. And the normalized y is equal to the actual y divided by the length. Fairly simple arithmetic, but unit vectors are actually really handy because they fit much better when you're doing things like cosine, sine, arctangent, etc. Now these two things go well together. You combine them, you get length and normalization. You can preserve an object's speed when it changes direction. So you get the length of the vector to preserve its speed, and when you work out the new angle, you find the x and y of that gradient of that angle, normalize it, and then multiply it by the speed, and you'll get the same speed in a different direction. Okay, so back to things in Monogame. First of all, the song class, dead simple. It just stores a long audio sample, a song, and there's not really anything you can do with that directly. It's used in other things, namely the media player class. Media player class is sort of like a jukebox. It can play songs, so you can tell it which one to play. It can pause, it can resume, it can stop. You can tell it whether to repeat a song. There's a bunch of other stuff it can do as well, but that should be enough to be getting on with. Now, if you want to detect that whether a key on the keyboard or a button on a gamepad has just been pressed, then what you need to do is store a keyboard state at the end of every frame, and then in the next frame you get a new keyboard state. So that gives you two keyboard states, one telling you which keys are currently held down, this frame, and which ones were held down at the previous frame. And if the two are different, one's currently held down and one's not held down, then you know that it's just been pressed right now. And vice versa, you do it the other way around. If it's currently up and it wasn't up before, then you know they've just let go. That stops you from responding to a key being continually held down by continually doing something every frame, which is usually not what you want. Okay, we also have the gamepad class. The gamepad has a get state just like the keyboard, and it returns a gamepad state object. You need to tell it which player. So if you do for instance gamepad.getState brackets playerIndex.1, then it would return the gamepad state for player 1. You can also set the vibration here for the left and right motors in the controller. So that gamepad state has a bunch of attributes. It's also got methods. If you can use isButtonDown or isButtonUp just the same as you would use isKeyDown or isKeyUp. But there's also attributes which are themselves other objects. So there's a buttons object with a bunch of buttons in them, a D-pad object with 4 buttons, an isConnected boolean, true or false, whether there actually is a gamepad in that controller. There's a thumbsticks object and a triggers object. We'll see them in just a moment. The gamepad buttons has attributes like A, B, X, Y, back, start, etc. All the buttons you can press on an Xbox gamepad. Each one of those is a button state. You've also got up, down, left and right buttons on the D-pad, which is the other element we saw. Those are also button states. The thumbsticks, however, left and right, are vector 2s. These represent the position of the sticks horizontally and vertically, with 0 being in the middle and 1 or -1 being fully held down left, right, up, down, depending on whether it's the X or Y part of the vector you're looking at. The gamepad triggers. These are two trigger buttons which can be held down. They're pressure sensitive, so they are floating points, with 0 meaning they're not held down at all, 1 meaning they're fully held down, and a decimal place in between being somewhere in between. But back to those button states, they're fairly simple. It's just a structure, an enumerated type, with two enumerations, pressed or released, so you can compare a button to one of these two to find out whether it's held down or not. The mouse class, again, you can use getState. It returns a mouse state. And in that mouse state, you have an X and Y component. These are integers, which is different from the X and Y in a float. So you may need to worry about that at some point. But these are screen coordinates, not necessarily window coordinates or viewport coordinates. So bear that in mind too. The mouse state also has a left button, right button, and middle button. These are button states, just telling you whether those buttons are pressed. So you can react to them the same way as keyboard or gamepad buttons. And that's all for now. See you in the next lesson.